Hello, today we're looking at logarithmic differentiation. Okay. So let's have a look at what we're being asked to do today. So we're asked to use logarithmic differentiation to differentiate the following. So y equals x cubed plus 3x squared minus 1 over the square root of negative x squared plus 4. So we could use the quotient rule, but we're asked to use logarithmic differentiation. Let's see if we can. So what this means is we're going to take the log or the ln of both sides and see if that helps us. So let's do that. So we're going to take ln of the left-hand side. So ln y equals ln of the right-hand side. So x cubed plus 3x squared minus 1 over the square root of, let's write this as 4 minus x squared. All right. So now we can use properties or rules of logarithms on the right-hand side and see if this makes our life easier. So when we have the quotient of two numbers, or if we just have a quotient or functions in this case, and the logarithm of that quotient, then we can use this rule where we take the difference. So the ln of x cubed plus 3x squared minus 1 minus the ln of the square root of 4 minus x squared. Okay, and again on the left-hand side we have ln of y. Okay, so let's continue with this and see where we end up. Let's simplify the right-hand side a little bit more. Okay, so we can't simplify this first term anymore. We just have ln of x cubed plus 3x squared minus 1. However, ln of square root of x minus 4 minus x squared we can write as ln of 4 minus x squared raised to the power 1/2. Okay, just copy this out because it doesn't change. And then again, using the rules of logarithms, we can bring that 1/2 down and multiply. We have 1/2 times a ln of 4 minus x squared. All right, so we haven't taken the derivative yet, but it looks like it could be a lot easier. So now we're going to take the derivative of both sides. So what is the derivative of the ln? It's 1 over whatever the ln is being applied to times the derivative of that function that we're taking the ln of. So in this case, it's 1 over y times y prime on the left-hand side. Now we're going to do the same thing for each of the terms on the right-hand side. So 1 over x cubed plus 3x squared minus 1 times the derivative of what's in the bracket. So 3x squared plus 6x, right? Then minus, okay, again, 1/2, let's remove that, times 1 over, let's put some brackets so we don't get confused, 4 minus x squared times what we're taking the ln of, so negative 2x. Good. Okay. Let's see if we can reduce the size a little bit. Okay, so now the goal is to solve for y prime. So y prime equals y times all of this. So brackets, let's clean this up a little bit. 3x squared plus 6x over x cubed plus 3x squared minus 1 minus, looks like we cancel out these 2's. We have 2 negatives, so that makes a plus. Let's put that plus in, plus 2 over 4 minus x squared. Now what is y? Let's go back up to the top. Whoops, let's go back up to the top. This is our y right up here. This is our y, so let's plug that in below. Again, let's make this a little smaller so we have some more space. Let's see everything. Okay, we have just enough space. Let's write the final answer in. So y prime equals, what does y equal? It equals x cubed plus 3x squared minus 1 over square root of negative x squared plus 4, all of that is being multiplied by everything in these square brackets. Good. I'm sure you can make this a lot neater and simplify. I will leave the simplification for you as an exercise, but this is our y prime, and a lot easier. I think it can be a lot easier than using the quotient rule directly. Good. All right, so let's look at the next exercise. Okay, so our function is y equals 3x squared plus 2x, all raised to the power negative 4x plus 5. So we need to use logarithmic differentiation to find the derivative of y prime. So let's take the ln of both sides. All right. The same process. And again, on the right-hand side, we're going to apply the rules of logarithms before we start differentiation. So we're going to bring this exponent negative 4x plus 5 down and multiply by ln of 3x squared plus 2x. Good. And now let's differentiate both sides. So we have 1 over y times y prime equals, now we need to use the product rule on the right-hand side. So our first function is negative 4x plus 5. Derivative of this is negative 4 times ln 3x squared plus 2x plus, right, we have negative 4x plus 5 times the derivative of this ln. So we have, let's see if we create a little more space for ourselves. 1 over 3x squared plus 2x times 6x plus 2. Good. So now, we need to simplify everything and solve for y prime. Let's see if we have enough space to do that. So y prime equals y times this huge mess here. Okay. See if we can make this a bit neater up here. Good. And what do we have? I think we have 6x plus 2 in the numerator. Good. And do we have enough space? I think we might just have enough space to put in our y. So y prime equals 3x squared plus 2x raised to the power negative 4x plus 5 times negative 4 ln 3x squared plus 2x plus negative 4x plus 5 times 6x plus 2 all over 3x squared plus 2x. Oh, sorry, that's y prime. Good. That's how we use logarithmic differentiation to find the derivative of these very messy functions. Good. So this brings us to the end of our session. If you have any questions, send us a note at info@raisemymarks.com or by phone, day or evening. We look forward to hearing from you. See you soon.